Last bit of the assess then, I'm doing question 7, that's this one. In this diagram, TA and TB are tangents to the circle and the centre is O, just there. And it says use your knowledge of angles to show that the triangles TAO and triangle TBO are identical, congruent. Well, let's just put in some more information there, shall we? So that joins to that 'cause it's a radius, and that joins to that 'cause it's a radius, and this centre joins to the point T. So I've got to prove that these two triangles I've just constructed using the red lines are identical. Well, of course they are. Well, here's the first thing I'm going to tell you. I'm going to tell you that angles formed by the tangent to the radius is always 90 degrees. So that's 90 and that's 90. Well, there you go. I've now got a 90 degree angle. They share a common hypotenuse, TO, and what is more, the length here, AO, is a radius, and the length here, OB, is a radius. So what have I got? I've got right angle, hypotenuse, and a common side. Let me tell you something else as well. The length AT and the length BT are also identical, because if you have tangents which are drawn to a circle and they meet a common point outside the circle, the lengths are always the same. So therefore I just want to show that that is the same as that this radius is that radius, and that these two triangles share a common hypotenuse. Therefore, for all these reasons, these triangles are congruent. So let's just begin to put something down as written evidence. So what do we got? Going for black now. We have got AO and BO are radii. Let's just make it obvious, of the same length, obviously. Same thing. I also want to say that OBT and OAT are right angles, because tangents AT and BT form a right angle with the radius. AO and BO, or with the radii should I say, they form right angles with the radii AO and BO respectively. In other words, AT forms a tangent, is a tangent and forms a 90 degree angle with AO, and BT forms a tangent with BO, is a tangent that forms a 90 degree angle with BO, and I've demonstrated that. So that's the two things I can say. And I'm going to say triangle OAT and OBT share a common hypotenuse, and the hypotenuse is OT. Therefore ATO or OAT makes a difference. Therefore triangle ATO, let's just be consistent, I'm getting tired, never mind. Therefore triangle OAT and triangle OBT are congruent because of the RHS rule. Okay, they have a right angle, and I've stated that. They have a common hypotenuse, and I've stated that, and they have one other corresponding side, the radii, and that's all I want to say about that. Please note, these sides are also corresponding, the AT and the BT, because I've said that tangents converge to a common point, have the same length. They also have two radii, both the same, and they share a common hypotenuse. Therefore, they're also congruent because of the SSS rule. But I won't state that. I've said it, but we don't have to write down all the reasons. But I've shown that these two triangles are in fact congruent. And that's it. Last question. Right. This is the AQA style question. It is in fact a past question from a paper. In the diagram, ABCD and PQRC are squares. Use congruent triangles, your knowledge of, to prove that DP equals BR. Right. DP equals BR. Let's just have a look here. Loads of ways of doing this. So this is a square, therefore DC equals BC. Let's just say it straight away. DC equals BC because they're sides of the square. Is that alright? I forgot to put the E in the word sides. Sides of the square. And also PC equals length CR. PC equals CR. Sides of the smaller square. And that's called PQRC, isn't it? In fact, let me just define the square. Sides of the square ABCD. Since we're going for an A star proof, let's do it properly. And that should have an E there somewhere. Again, I'm not very good at doing E's with this little pen. So that's that. So that's two statements. So I've said that equals that, and I've said that equals that. Now, let's just take a look. Yep. I'm going for this angle right here. Angle PCD equals angle CBR, that one. Sorry, RBC. Yeah, RBC. Sorry, RCB. RCB. Let's just check it again. So PCD, yep, equals RCB. So that's the same as that. And I should fill it in really so it looks nice and pretty. So that is the same as that. So I've created a situation whereby I have a side angle side. Look at it. Side angle side. Yeah, very good. Therefore, in triangle PCD, the rule SAS is true. The rule SAS is true. And in triangle BRC, the rule SAS is also true. Therefore, what have we got here? Therefore, DP equals BR. Just study that one. So this side here, if I've got DC is the same as CR, and the yellow angle PCD is the same as angle BCR, and I've got the length CD equals BC, so I've got a corresponding length, a corresponding angle, and a corresponding larger length. Therefore the two triangles are congruent because of the ASA rule. Therefore the length DP must equal the length BR because they're part of the two corresponding, because they're part of the two congruent triangles. Therefore DP equals BR because they form part of the congruent triangles. And let's just name them again. DCP and I don't know, RBC respectively. Alright, so I'm saying that's part of that and that's part of that. And that's all we need to write down, worth about 4 marks, and that's probably grade A or A star, I think, because getting your head around all these different rules. And that's it, the assess is done. Please study it. Forgive me for getting all glitchy and missing out the E on the word sides, but I'm still learning to use this and this doesn't always respond. Right, study carefully, It's a little bit tricky in places, and I'll see you in chapter 16.